Are you guys able to see the screen before we move on? Momsan?
Yes, sir.
Okay, great. Now, when the two spheres are separated, the charges on the two spheres will be the same. That's the process you're going to be getting in your papers. So in this case, we have a minus 4 times 10 to the power of minus 12 and minus 3 times 10 to the power of minus 12 Coulomb spheres. At the end of the separation, they will both have the same charge because electrons or negative charges will flow from the sphere with a lot of electrons to the one that does not have a lot. Mamsan, between the two spheres, which one has excess of electrons?
Sir, is it not the first one?
It is the first one, that's correct. That means electrons will move from which one to which one? Mamsan?
Electrons will move from the first one to the second one.
That's correct. Yes, but however, we all know that like charges repel and unlike charges attract, meaning a negative charge and a positive charge will always attract. However, in this case, we will assume that whoever is doing an experiment will be able to get these two spheres into contact by force. So that's what we must get into our minds. Because I know you might be asking yourselves, how come we are expecting a contact between two unlike charges? We are just assuming that whoever is doing the experiment will be able to bring these two charges into contact. So we will apply the same principles that I was explaining earlier on. Two spheres are going to be brought into contact, and during the process of contact, there will be a flow of electrons until all the spheres have the same charge. And then after that, they will be separated. And all of them will contain the same amount of charge. Okay, now calculate the direction of force that A exerts on B. Mamsan, do you remember the formula?
So which formula?
The formula for the force that is exerted between A and B.
No, sir.
Do you remember that I talked about an inverse square relationship?
Yes, sir.
And I explained that the force between two masses is given by, do you agree that it is given by G, M1, M2, all divided by R squared? That's the inverse square relationship. So it is similar to the charges. This is what you're gonna get. You remember this?
Yes, sir.
Okay. So the value of K, unlike G, it is given by 9 times 10 to the power of 9. So the force exerted between A and B is given by let me see, question number 1. Let me shift this portion. Okay, so at 1.1, we know that force between A and B is given by KQ1 Q2 all divided by R squared. This is equals to, the K is 9 times 10 to the power of 9 times Q1 is given by minus 4 times 10 to the power of minus 12 times minus 3 times 10 to the power of minus 12, all divided by Mamsan, what is the distance between them?
So it's 5 centimeters.
5 centimeters. But the units must be in meters. So how much will it be?
Will it not be 500 meters?
No.
5,000?
Will
Also,
it not be
Do you agree?
yes.
Squared. So when we calculate, it will be equals to, let me check. It will be equal to 4.8 times 10 to the power of minus 21 newtons. So before I move on, do you remember that with Newton's gravitational law, there's a force equation and also the field equation? You remember this one? Mamswan?
Yes.
Okay, so it's gonna be a similar story with charges. In this case, we have this equation which talks about the force between two charges, and we also have the formula which talks about the electric field strength, which is similar to the gravitational acceleration that you need to calculate when you're dealing with uh, with the gravitational law. So your strength will be K Q over R squared. So these are the formulas that you're going to be using a lot in electrostatics. So question 2 says calculate the new charge of each sphere. Kagiso, how do we calculate the new charge for each sphere?
We're gonna use the formula Q naught is equals to Q1 plus Q2 over 2.
Q new equals Q1 plus Q2 all over 2. That's
2.
correct. So that will be minus 4 times 10 to the power of minus 12 plus the other one was minus 3 times 10 to the power of minus 12 and all over 2. So the answer will be, Kagiso, it will be minus 3.5 times 10 to the power of minus 12. What is the units of a charge? Mamswan?
Coulombs. It's coulombs, sir.
Coulombs, okay. So be coulombs. Okay, so the second question says, how many charges are transferred? How many charges are transferred during the process? Mamswan, how do we go about this one? How many charges are transferred? Katiso, how many charges are transferred? Do you remember this formula? Q final minus Q initial. So, like I have explained initially, the process is two spheres have been brought into contact. And after contact, when they are being separated, they will each have the same charge, which in this case is minus 3.5 times 10 to the power of minus 12. So, Kalshi, so what will be the value of QF? Do you agree that Q final will be 3.5 times 10 to the power of minus 12? Then minus the initial charge will be, it's better to take the negative charge. So it will be, it's better to take the charged object with the highest negativity, which is minus 4. Times 10 to the power of minus 12. The reason why I use minus 4 is because this is where your electrons will be transferred from. They'll be transferred from a -4 times 10 to the power of -12 sphere. So that's the value of Q that you initial that you use. So in this case, we'll have -3.5 plus, because it's a negative times negative, plus 4. It is going to be 0.5 times 10 to the power of -12. So this is the change in Q. This is the change in Q. So what is the units of change in Q? It will be coulombs. So do you agree that only 0.5 times 10 to the power of -12 coulombs will be transferred from the -4 times 10 to the power of -12 coulomb sphere, or sphere A? Do we all agree?
Yes.
Okay. But now the question says, how many charges are transferred? Not what is the magnitude of um, of the charge that has been transferred. Do you guys remember this formula from grade 10? Mamswan,
Yes, sir.
do you remember this formula?
Yes, sir.
So what will be the value of Q?
0.5 times 10 to the power -12.
All divided by, what is the value of QE? You still remember this one?
Yes, sir.
Okay, so this will be, let me check. If you have a calculator, you can calculate as well. 5 times 10 to the power of -12 all divided by 1.6 times 10 to the power of -19. So this will be 3.125 times 10 to the power of 6 electrons transferred. Do we all agree?
Yes.
Okay, let me try to send an ID, a meeting ID. There's a couple of people that are struggling to get into the meeting. Let me see. I just hope they're gonna be able to get into the meeting. Okay, yes, so these are the amount of electrons that were transferred during the process. And at the end, the two spheres had the same charge of minus 3.5 times 10 to the power of minus 12. Now let's go to the next question. How does the magnitude of the force that the sphere A exerts on B after the change after contact? How does the magnitude of force that A exerts on B changes after contact? Mabswan, will it increase, decrease, or remain the same?
So it will decrease.
Why is it going to decrease?
So because I don't know.
It will not decrease. It will actually increase.
Why?
It will increase because force between two charges is given by KQ1 times Q2. Do you agree?
Yes, sir.
So the reason why it will increase is, let us evaluate the product Q1 and Q2 before. How much will it be? It was minus 4 times minus 3, which is minus 12, right?
Yes.
After
So it's
contact,
positive 12.
yeah, positive 12. And then after contact, you have minus 3.5. You agree?
Yes.
Times Q2 will be what will be the value of Q2 after contact?
4.
It will also be 3.5. I think I've explained this a number of times. When you separate the two spheres, they will both have the same charge. After separation, they will all have the same charge. Do you agree?
Okay.
Do you
yes.
agree? So 3.5 times 3.5, what is it?
12.25.
12.25. Which one is bigger?
12.25 is bigger.
Okay, is there an increase or a decrease?
It's an increase, sir.
It's an increase. It's an increase of a force. Not an increase in a charge, an increase on a force.
Yes.
Okay. Now we're going to 1.2. 2-point charges, Q1 and Q2, at a distance of 3 meters apart are shown below. Now the charge on Q1 is minus 14 microcoulombs, and the charge on Q2 is 20 microcoulombs, as shown in the diagram below. Now define the electric field strength. at a point. Ronel. Ronel, what is an electric field at a point? Mamswan?
Sir, is it not the electrostatic force experienced per unit positive charge placed at that point?
That's correct. So electric field strength, it is 1.2. Electric field strength, it is the amount of force experienced per positive unit charge. Force per unit charge. So that is the reason why if you have F equals KQ1 Q2 all over R squared. So if you replace this force, you're gonna have force equals E times Q. So if you replace E times Q, you will have K let's say for instance the second object was a test charge. So this is what you're gonna have. So this is another formula for calculating the electric field strength. And Q1 is the host charge. So when it comes to calculating the electric field strength, we have two major formulas. So whenever they mention electric field strength, these are the two formulas you must think about. If you are given the value of your positive test charge, then you must use this formula. But if you are given the value of a host charged object, a host charged object is an object which is charged, and then to test the electric field strength, the scientists use the so-called test charge. This is the host and this is the test charge. So the test charge is always positive. So to test the field of your charged object, if your host object is a negatively charged object, it will attract the positively charged test object. So when you draw the electric field around your host object, they will be pointing inwards. So these are the electric fields around a negatively charged object. So if you have a positively charged object, if you put a test charge is positive, it will be repelled. So the direction of your electric field shows the direction of movement of your test charge. If you put a test charge around a positively charged object, it will move outwards. The other thing you must know about electric field lines is that they do not cross each other, and they are drawn perpendicular to the surface. And the closer the field lines are, the bigger the strength on the surface or on that particular region. Okay, now let's go to the questions. Draw the electric field between Q1 and Q2. Now, the electric field between Q1 and the Q2 will be as follows. The question is 1.2.1. The first charge is a negative charge. And the second charge is the positive charge. If you put a test charge here, a negative charge will be attracted to it, but the positive charge will repel the test charge. So this is what you're gonna have. Okay. Please note that all the arrows are pointing towards the negative charge. Why? Because the test charge is positive. It will move towards the negative charge, but it will be repelled by the positive charge. So you will get all the marks by drawing that diagram. You can even put your positive charge, your positive test charge. And these two are the host charges. Okay, now let's go to the next question. It says, calculate the net electric field at point P. So if we put a point charge at point P, it will experience two forces. It will experience the force coming from Q1, and the other one will come from Q2. So the same applies with the electric field. It will experience an electric field coming from Q1 and the one that is coming from Q2. So at the end, we're gonna have to sum them up depending on which direction they are pointing. So, Ronel, which formula can I use to calculate the electric field? We have two formulas. We have two formulas. We have this formula whereby we are given a test charge, and we also have this formula whereby we have a host charge. So which formula should I use? Are we given the amount of charge for the host charge, or do we have the charge value for the test charge? Which one do we have? Mamswan?
Sir,
Which one do we have? Do we have a charge for the host, or do we have the charge for the test charge, the one that we are given?
we have the charge for the host.
Okay. So which host should we start with? Okay, let's start with Q1. So the electric field around Q1 E equals, so which formula should I use, Mamsan?
So E equals to K Q1 over R squared.
Okay, so what is the value of K? And the value of Q? Minus 14 times 10 to the power of Mamswan, micro. How do we convert micro? It's 10 to the power of all divided by the distance between the point charge and the host. Ronewa, what is the distance between the point charge and the host, Q1? What is that distance? Mamsan?
Sir, is it not 1 centimeter, 1 meter?
1 meter. That's correct. So it will be 1 meter to the power of 2. So this will give us how much are we getting there? This will be, I've also calculated it. It was minus 126 newtons per coulomb. So the electric field around Q2, it will be the same formula, but now the host object is Q2, all divided by R2. Before we move on, Ronel, what is the direction of the magnitude 126 Newton per coulomb? Which direction is it pointing? If you put a test charge around Q1, which direction will it go? Atliso, which direction will it go? If you put a positive test charge around Q1, which is negative, do you
Well,
agree if I say that? You think?
I think I go to the left.
That's correct. That's correct. Because we are dealing with vectors, I'm going to write 126 to the left. Now, E around Q2 will be 9 times 10 to the power of 9 times the charge is positive 20 times 10 to the power um, of minus 6. Did you guys got the same answer? I think I made a mistake on the answer. How much did you guys get on the previous question? So let me do 9 times 10 to the power of 9, then times 14 times 10 to the power of minus 6. I got minus 1.26 times 10 to the power of 5. So this is 1.26 times 10 to the power of 5 to the left. The answer is in newtons, sorry. It's in newtons per coulomb. So the second one will be, what will be the distance between the point charge and Q2? Ronel. The point charge P and Q2. Katiso? The distance between the point charge P and Q2. Mamswan, do you agree with 2 meters? Do you agree with 2 meters? So the answer that I got was 9 9 times 10 to the power of 4 newtons per coulomb. Does anyone have any questions so far? Because I can see we are running out of time. Does anyone have any question? Mamswan? Yeah, I see we are running out of time. I urge that you go and complete the task that we are doing so that at least we can be in the same page, because this is the last chapter of term 1. So once you get all the steps correct, then we'll be able to be in the same page in the next segment. So if you have any question from Newton's law up until Coulomb's law, I urge that you go and collect all the questions. So what you need to do is you go and practice whatever question that you find hard. You just need to set it aside or DM me with that question. But you also need to do the problem as well. You need to send me the question and the solution as well. Then I'll be able to help you. So from now onwards until March, we're just gonna be doing revision of what we have been doing. So I will see you guys on Thursday. To be Thursdays 7 o'clock. Thursday 7 o'clock. So we're gonna finish off what we're doing, and then we're gonna start doing what we've been doing. Newton's law and electricity. So if you have more questions on Newton's law, just go and collect as many as you can have before we write the tests, because we're gonna write 2 tests before you write the exams. Before you write your original tests. So I'll see you guys on Thursday.